Does that make sense? Does that work out to, in fact, 8/6 or 4/3? If you look at it, you got -1/2, -1/6, which is -4/6. -4/6 times 2 is -8/6, which is -4/3. Yes. And then the next one, well, if you tilt your head and squint, you can see obviously that's 1 over 120 times 2x to the 5th, right? If I must. 1/24 is 5 120ths, so 5 plus 1 is 6 120ths, 6 times 2 is 12 120ths. But then, did I miss something? Oh. Yeah? Did I miss a term? Oh, my bad. Thank you. I was like, this does not quite work. So -1/6 times that gives us a what? Plus 1/12, right? X to the 5th? Yeah, thank you guys. So now I've got 5 plus 1 plus 10. 16 times 2, 32 over 120, also known as 2 to the 5th over 120. So do you guys know what the next term is? What is it? I don't know the number, but it would be minus what? 1 over 7 factorial, right? 2x to the 7th power. How do I know that? What am I doing? So this is, again, sort of a math prank. This is the sine of 2x, right? Because the sine of 2x is equal to 2 times the sine of x times the cosine of x. So, of course, if you multiply these series out, you should here's a thought. You could prove trigonometric formulas by multiplying series. Suppose you didn't know that the sine of 2x is 2 sine x cosine x. You could derive it by multiplying these series. I don't think that would be a very efficient derivation, but it's something you could do. All right. Questions? What's the power series for secant? I don't think we've done that one yet, have we? So I should probably do more multiplication for you guys, but that's a good start. So how about secant? What is secant? What's the domain of secant? Secant's what? It's 1 over cosine, right? So this guy gets into trouble at odd integer multiples of pi over 2, right? Pi over 2, minus pi over 2, 3 pi over 2, minus 3 pi over 2. These are bad news, right? It's got vertical asymptotes at those points. But certainly at 0, it's all fine. It's all hunky-dory. So we can find the Maclaurin series for secant, right? We can try that. And the brute force way is to use your theorem.
Agreed.
So f of 0, secant of 0, which is what? That's 1 over cosine of 0, right? Which is 1. What's f prime of x? Remember, it's secant x, tangent x. So therefore, f prime of 0 is 0. Is this surprising? It shouldn't be surprising to you, because the Maclaurin series for secant should be an even power series, because secant is an even function. So we already expect from the outset that only the odd terms are non-trivial. right? That's what we call situational awareness. So then this is going to hurt a little bit. F prime prime is, well, it's secant x, tangent squared x, right? Plus what? Secant cubed x by the product rule. So therefore, f prime prime of 0 is 1. This is as far as I feel like doing at the moment, all right? So what is the Maclaurin series for secant? Secant of x apparently is equal to 1 plus 1/2 x squared plus dot 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 dot. Is there another way to find the Maclaurin series for secant? Well, there is. We can do something called division of power series. We know the power series for cosine, right? And secant's 1 over cosine. So check this out. So secant, 1 over cosine, right? What's the power series for cosine? It's 1 over 1 minus 1/2 x squared plus 1 over 4 factorial x to the 4th minus 1 over 6 factorial x to the 6th, and so forth and so on, right? So how do you do that division? How many ones? How many multiples of this do we need to get the 1? So then I put that down here. I subtract. I get 1/2 x squared minus 1 over 24 x to the 4th plus dot 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 dot. How do I get rid of 1/2 x squared using a multiple of the series? What do I multiply by? 1/2 x squared, right? Now here's where it starts to get interesting. See, because then I multiply that by that, and I get 1/2 x squared, and then I get what? Minus 1/4 x to the 4th plus dot 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 dot. So I take the difference of these. What do I get? The 1/2 x squared cancels. 1/24 minus a minus 1/4 is like minus 1/24 plus 6/24, which is to say, I think it's, I want to say 5/24. Is that right? Yeah.
Where'd you get the 1/24?
Oh, that's the third term in the power series, the Maclaurin series for cosine. 4 factorial is 24.
Okay.
It's bugging me. I feel like I've made a sign error, but anybody think different? Well, unless I'm making a mistake, plus 5/24 x to the 4th. Do you guys have any other ideas of how we could process this one? Any other ideas? Any bold ideas? That may or may not work. So here's a place you could get in trouble. You could try to do geometric series on this, right? Here's a particularly horrible thought. Think about this in terms of geometric series with all of this being R. but you have to think about factoring the minus out, right? So then 1 plus r squared, what would that look like? You know, 1 plus 1/2 x squared minus 1 over 24 x to the 4th plus dot 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 dot, right? And what's r squared got in it? That's where it gets kind of dicey, right? But r squared, the lowest order term in r squared is this x squared times x squared, right? Which gives me a 1/4. So it seems like I should get plus 1/4 x to the 4th from this r squared term. Which is what I had, right? So that is 5/24. Okay, so I got the same result. You must be right, yeah. Yep.
We're only concerned with order 4 here, so why do you, is that, are we, so why you?
Oh, just because we're out of time in class, I couldn't go past order 4. It's not a good reason, it's just a reason.
Okay, that's good.
But you can divide to whatever order you want. It's just a pain. So